So this kind of thing we have done in linked list, so that next time when we are writing functions like search, delete, and we need a very big tree, we can call this function rather than doing insertions as many times, right? So let's implement this code here, and Lokesh will tell what should be the logic. Yeah, Lokesh. Create random BST. It takes two parameters. One, it tells how many nodes we want to create in the tree, and what is the max value. Ideally value will take randomly, but what is the max value you are specifying? Yeah. Speak up. What is the code I should write? Okay. For loop for.
We initialize as in time.
Mm-hmm.
We initialize as
We'll initialize I. Okay. Int I for I equals 1 to
less than node count
I plus plus. Okay. Then
rand
okay, we get a rand percentile max value. This gives us a random number. We store it in J. Okay, then we'll insert using which function? We have written insert function already. So using that function we can insert this value in the BST. How do we insert? Insert BST node. What is the first parameter? It's coming there. Root and element type. Root. Do we have root? No. Okay. Then second is data. What should be the data?
Data will be rand.
J. Can I say J? Okay. And insert BST node also returns the new pointer. Are we done with the function? No. What is missing? Now this is open to everyone. What are the things missing in the function? This is not yet complete. J we have not declared. Now is it complete? Element type?
Instead of int.
Okay, instead of int, ideally J should be of element type. That's a good point, yeah. Element type J.
Node count and max. Node count and max.
Yeah. So Lokesh, this is something you should hear too. Rishank, tell what are you saying?
For node count and max value also element type. Input parameter.
No, I didn't get
Instead
you.
of int, you must use element.
Here also, for node count it should be int. How many nodes we want to insert? Max value, it can be element type. But node count is fixed. It's an integer, right? How many nodes we want to create? Max value should be this. Then, anything else missing? There is a problem in this line. It should be less than or equal to. Otherwise, it will insert one node less. It should be equal to. What else? Root is unknown variable. So how should I declare root? BST node star root. What if we don't assign null to it? It will contain garbage. When we call insert function checks if root is null only, then it creates a node and return. So if we leave it without initializing, it will crash. So this is important because insert BST node is dependent on this. Now is function complete? Ajay, is it complete? Return. What should we return? Root. Because it has a return type of BST node star, so we should be returning the root of the tree that we have created. Now I don't know how big tree that print ASCII can print. Now we are capable of generating any length tree, right? We can insert even 100 nodes. But print ASCII will run short of space in printing the tree. Which header file contains rand? stdlib. Easiest way is you right click rand, you say find declaration of rand. It will open a file. What is the name of the file? Any function we want to know, just right click and say take us to the definition. So you are right, it is stdlib, and we have that included already because we are using malloc. So even that problem is resolved. And we are not using any other function here which is coming from any external header. So this function that we have written, this signature, just copy and add it to our bst.h. So create random bst so that we don't need to provide a forward declaration. And reason we have written this function is because when we write unit test for search, we'll create a big tree and then search in that. And whenever we write for delete also, we'll create a random tree, delete from there. So now I can call this function. Now in main, above main I'm defining a function void search unit tests. Just a function void, we don't need to return anything. Search unit test. There, first thing I'm going to do is bst node star root equals create random bst. How many nodes? 20. Max value 100. And then we call print ASCII. We just want to see whether the tree is correct. So after doing this, we make a call to search unit tests. Until now we have not written the function, we have not made the call to function. That is what we will do next. We have just set the ground for our search unit tests. Now if we run this, we are seeing a bigger tree by just making one function call. Does it have 20 elements? 1, 2, 3, 3, 1, 4, 2, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Why it has 19? Why one less? Because we made a condition. In binary search tree, we will not be inserting duplicates. If random number gives duplicate any time, we are not creating a node there. So it's random. So even though we have said 20, ideally we could have ensured this if search function was there. Before inserting search, if that is found, then generate next random number. But we are not going to that complexity. Right now it's fine to stick to this. But we should know the reason why less number of nodes are coming. And now let's implement our search node. First, let's do the binary version. BST node, in the end, pasting this. Lokesh, how do we implement recursive version of BST? So thing that you have to tell is, when will we make recursive call? That's the thing we want to put first. There. See, we are getting root, we are getting data. Recursion is all about, if it knows the answer, it will tell, otherwise it will refer to someone else. That is recursion. So first thing to check for recursive call is,
Whether it is null.
okay, if root is null, what does that mean? Will this data be there in the tree?
Sorry.
If root is null, what do we do? This is fine.
Root is not equal to null, we continue.
If root is null, what we do?
Returns.
What should we return? It has to return the address of the node. If root itself is null, does the node with data exist? No. What should we return? Whose address? If node is not found, you should return null. The caller will check. If it is returning null, that means node was not there. This is clear why we are returning null? Because see, search function we are saying, it will take a root and data from us. If it finds the node, it will return the address of the node. If it does not find the node, it will return null. Simple. Now, if root of data matches data, the data we are searching that's there in the root, what should we return? Return root. Simple. So these are the two cases in which this function can answer itself. What are the conditions left if none of this is true? If root is not null and root of data does not match the data, then how do we search? Left and right. So first is, if our data is less than root of data, we should search on left side. So because we are writing recursive, we don't want to go down, we want to tell it to someone else. So we can do recursive call r search BST node, same function we are calling again. Who is the root now? Root of left. Now we are saying you are the root and data remains the same. And whatever it returns to us, it will also return the address. Same address will return up. So we should say return. This is important. If our data is less than root of data, then we are saying whatever answer root left gives, same answer we are returning again. What is remaining now? There is an else case.
Return.
Rather than writing else, we can directly write return whatever if right of data. So this is recursive call, that's it. So only three conditions were there. Either it will match root data, or it will be left less than that, or it will be greater than that. All cases we have addressed, including root null. Because in recursive call, it's possible that if our data is less than root data, if it is an invalid case, let's say the case we are talking about is 3 and 2, and we are searching 1 in it. In this tree, if we search for 1 is less than 3, it will make a recursive call with 2. 1 is still less than 2, it will make a recursive call again with null. Now if we have to call this function from main in our unit test, first we want to see what is the random tree that is being built. Since we are not using srand, we are not setting the seed, we are sure our tree will be same in all the cases. Right? If I run it again, we will see root is 41, this is 67. Run it third time, root is 41, this is 67. Because we are using rand without using seed. So What is the positive case in this? Where we'll find a search value. Let's give 78 or 81. 81 is a positive case. Searching for 100 is a negative case. In case of 100, search should return us null. So two cases, and both the cases we should validate. 81 and 100. So how do I write my unit test? Ajay, how have you written unit test? Search root of 81. You put that if else condition.
Yes.
If this is null,
Not found or empty.
okay. So can I put in one line with assert? We know this value should be there. So we are saying assert 81 should not be null and assert 100 should be null. So this becomes a unit test. If program does not crash, we can assume value was found. Other way you use is if else. If this is not null, it is found. If this is null, it is not found. That is what we do. So here I am using assert and I am including assert.h so that our unit tests are automated now completely. So this is clear, Lokesh? Assert, you remember we talked about? So now if we run this, there is no crash, that means it's correct. If I would have given value 43, we know 43 is not there. If our test fails, it would have crashed like this. So we have to be cautious in what values we are giving for positive and negative cases. Then and let's talk about iterative case now, which is not recursive. We have written this search. So that means without recursive calls, if you want to write with the help of loops, how will this function be implemented? So same check here. If root is null, value not found, we return null. If root ka data matches, we return root. Otherwise, we run in a loop. While, let's take root in a temp. While temp not equal to null,
Check with the data. Check with the data.
check with the data. If temp of data matches data, what we return?
Return
Temp,
temp.
because we are going down in the tree. If temp of data,
Already
yeah, we will remove that later on. If temp of data is less than our data, then our data is on.
that's right.
So we change temp is equal to temp of right, else temp equals temp of left. So this way we keep on going in the tree. Temp keeps on changing. Now both these conditions, are they needed? They are not needed, right? Because if root was null, temp will be null. Here it will come out of the loop. So when we come out of the while loop, if we have not returned here, what should we return? Temp or null. Null is more appropriate here, because when we have gone over the complete loop, anywhere if the match is not found, we would have not returned. We come out and we return null. Now these things we can remove. Because that is already taken care by the loop. Now if we want to test recursive iterative version also in the same program, here we can make a copy of these two lines, two assertions, and rather than calling recursive, we call iterative. Now whatever answer recursive gives, iterative should also give the same answer. and we run it. No crash, that means working. So this is clear.